Hello, guys. Welcome back to our course, Digital Design with VHDL. And today we're gonna, explore our first lesson in VHDL. So we're gonna learn how to download Modelsim, our simulators that we're gonna use to, model and simulate our designs. Also, I will explore with you, a very simple design of AND gate, and also how to use this design in another design. Okay, it's a very simple tutorial. So let's start. So as you see here in the screen, in the shared screen, here is the model sim that I am using personally, which is a model sim 19.1. It might not be the same as the one that Dr. James is using with you, but it doesn't matter. I mean, I prefer 19.1. If you are using another version, it will not be much difference. Okay. So with 19.1, I will share with you in the description this link here, just to get into this page. Then in this page, you choose the version, which is 19.1. And then once you click here, you will have three options: the Pro Edition, Standard Edition, and Light Edition. You can go with the Standard or the Light, you know. So once you download any one of those, okay, you can go with the light because it will take small space in your disk. You can go with the light. Okay, once you install it, it's really easy in installation. I already installed it, but if you have any problem, just let me know. So once you install it, okay, you can go here to the start menu, and you can just write model sim here. Yes, and you just open it like this. Jump start. Okay, open a project. If you don't have a project, okay, of course you will not choose open project. So for you, you just create a project, okay, and call it whatever, call it your name, because basically it's different here. It's a little bit different here rather than the programming language that you used before. So one project here we will put all our designs that in the same project. All our designs. Okay. It's not that one project for just one design only. So it will be a headache for you to create a new project each time to create a new design. Okay. So we just create one project and we will just dump everything we created in that project. It doesn't matter, you will not see much difference. Just a headache of creating a new project each time. You will just avoid this part. Okay, so I already have a project. I call it. It will appear to you. I call it Endgate in the beginning, although it has many advanced design now. So I opened it now. Okay. Here, once you open a project, you will see all your designs. Here are all my designs that I did before. So today I'm gonna go with you with a very simple one, which is creating just an AND gate. Okay, just like this one here. So let's, open it a little further now. Okay, so this is AND gate. So what we have here, just like any standard language, first you include some files. Okay, you define some libraries that you're gonna use. Okay, basically in each design, we're gonna use IEEE library. Library just like libraries in, for example, C or C++. If you wanna use add or subtract or sine or cosine, for example, you should include the math library. Okay, exactly the same way here. Okay. So in specific, we are using this standard logic, okay, library, because we are using a special type of variable, which is input and output here, which is called the standard logic. We will get into that. Okay, but they just use this all the time, even if you will not use it. But maybe if you have a very big design, most of the time you will go back and forth and modify it. So maybe if you are not using standard logic in the first time, maybe further you can use it. So just to avoid having errors and you cannot debug it easily, then include it in the first place. Okay, so here is my, very simple AND gate. Okay, actually, it doesn't need to be in a file because it's just one word here and that's it. But this is just for the sake of demonstration for you to make it easier for you. Okay. So basically, any VHDL code, I believe Dr. James has covered this, but let me go with you, briefly on that. So you have entity and architecture, and you can think about this entity as the function prototype. If you guys remember any programming language that you used before, there is something called the function prototype, in which you put a line of code before, for example, in C++, you put a line of code before the main function. And in this line of code, you define the functions that you're gonna use afterwards inside the main function. Okay, like for example, what's the return value? For example, integer int, the name of the function, and its input and the type of it if each input. Exactly here, the entity here is exactly the same. Okay, so basically I named my design here and underscore gate, and you can include underscore in your names. Okay, and the common practice here is that you name the file as the name of the, I'm sorry, you name the entity exactly as the name of the file, but it's not mandatory, but it's a good practice. Okay, so here my file is called and gate, and the entity is called AND gate. So is this entity just you define a box, as I said, a prototype. So this box has ports, the inputs and the output. Okay, the outputs. So in our box here we have two inputs because and simple AND gate has two inputs and one output. So we have two inputs, A and B. They are in. Okay, and the type of A and B is a standard logic. So in a standard logic in VHDL is basically you are defining them as wires because wire can have any value. An electrical wire, okay, it can have high voltage, low voltage, which are the normal values in Boolean functions. But as a circuit, might be this it might be gun float, or open circuit or something. So undefined, which is Z, okay, is also a possibility, floating, which is neither high nor low. Okay, that's why we like all the time to be close enough to the hardware level because this is basically a hardware description language. So we define our inputs and outputs as a standard logic. Okay, Y is output, and it's also standard logic. Then you write in the end of the entity and negate. And you might think here that because I'm mixing lowercase letters with uppercase letters that VHDL is case sensitive. No, it's not. So VHDL is case insensitive. It's not sensitive to either capital or small letters. Okay, you can just write anything. I can just change in and make it lowercase, and it will be just fine. Okay. Okay, so this is the first part, which is called the entity, in which you just define your circuit, your design as a box, and this box has some inputs and some outputs. Now let's go to the second part, which is the most important, which is you define basically what's inside this box, your architecture. Okay. So there are two ways of defining architecture, either behavior or structure. Basically, we are giving here, a name. This is just a name, but there are two types of architecture. Basically, you can define the circuit as standalone circuit. You can say it like by its behavior. So you can define a circuit or describe a circuit using its behavior. So basically, what's inside the architecture here will be the behavior of the circuit. Okay, and sometimes this behavior can lead to inoptimized design or unoptimized optimized design. I mean, higher number of gates. Okay, maybe the behavior is good. Okay, I mean the behavior is exactly what you want, but maybe the design itself is not optimized. I mean, you have redundancy, some gates that you can just avoid, but still, and still get the same performance or the same function. Just like the minimization that we see. So we see too many circuits that have two versions. One version is optimized, the other version is not. Okay. So you can just give any name here of this architecture, but we like, it's also common practice to describe it with its type. So here it's a behavior, so we write the name as behavior. But you can say, you can name it whatever, Mustafa, for example, you can name it your name. Okay. Of, this is a keyword, you should write this, and gate, the name of the entity, then is. So this is the structure of this line here. Then we have the word begin, the beginning of the description of the architecture. Then you put here the architecture, I'm sorry, yeah, the architecture itself or the design behavior. Okay. Then end, and put the same name of this architecture, whatever it is. Okay. Okay, so now let's go to the what's inside the box. Our circuit should be an AND gate. Okay. And the output should be a relation, a function of the inputs. Here is how we assign or describe the function of the y, or how y is assigned to or related to a and b. So this relation here is, or this operator, we can say, is assignment operator, our assignment operator. Here we are saying that assigned to y, a and b. And here is a keyword. Whenever the compiler will see and, it will realize that this is an AND gate or AND behavior. Okay. Very simple design. Good. Now we finished our, let's assume that we wrote this from scratch. We want to now compile it. Maybe there are some errors. Okay. So let's, for example, create an error. So let's, for example, you must write here the semicolon. So let's remove the semicolon and see. So we make compile all. This is basically the, the bad or the disadvantage of having, everything in one project, because it will compile all of them. But if you create a new project for each design, then it will just compile the number of files inside this project. So it's a pros and cons. But I prefer personally, to have everything in the same project. But anyways, now, surprisingly, we don't find any errors, 0 errors. Okay, why? Because if you get back here, we didn't save. Look, we didn't, it's active. Once we do that, now it's saved. Then if we compile again, we'll find the error. Yes, one failed with one error. So let's see the error. It was, in the beginning here. Go back. Oh, it's a lot. You can just navigate here using this scroll. Yes. Okay. So look, compile of AND gate, the name of our file here. This file is called AND gate. Failed with one error. So let's see. Expecting a semicolon. If we, go here, expecting a semicolon. Okay. If we, so before that line, there should be a semicolon. That's the meaning. So if you put a semicolon here, okay, and compile again. Oh, we still have an error. Why? Because we did the same mistake again. We didn't save. And I intentionally didn't save. I didn't forget. Why? Because basically this is a common, mistake that you're gonna do all the time. So I wanna, show it to you that whenever you have fixed something and this stuff didn't appear, I mean, you have the same mistake, the same error again here. That means it didn't save. One of the reasons, or of course, maybe your fixing was not right as well. But this is a common mistake. Okay, so please, save whenever you write something. Let's now compile because we fixed the error and saved. Yeah, zero failed. Okay, that's good. Now, this is a design, and it's nothing if we didn't verify it. We should, yeah, verify that's really an AND gate. Okay, so the second step is to do write what's called test bench. A file that you test with it your design. So let's go here. I have this. Yes, AND gate test bench. And again, look at the name of the file. It's called AND gate test bench. So usually it's a common practice to name the test bench file with the same name of the file or the design that you are simulating, which is called AND gate, then underscore test bench. So you know that this is a design, this is a design, this is its test bench. Okay. Here's this test bench. Again, you are hearing, it is just a VHDL file, but with a different purpose. Okay. So in that we are not defining a new design, although it's still a VHDL code. So a VHDL code always expecting an entity. So, but since this is not a design, the entity here will be empty. Okay, good. Now for the architecture. So we put a name, and it's good practice to name it same as your design and the gate. Then we put underscore test bench. Okay, of the name of the entity. Remember, we have entity, but it's empty. And a common practice to name this empty is call it and the gate underscore test bench. Okay, you can name this TB and this guy call it test bench. You write it TESTBENCH, whatever you want, but they should be, two different names. And a common practice, a good practice to add this test bench, either TB or test bench, and the name of the original design that you want to simulate. Okay. Then you copy and paste. Don't write it again. Copy and paste the entity here. Okay, just copy and paste. This is here. This is just copy and paste. Okay, and look at this component, because you are just simulating something, a design that is already there. We use component. Okay. So here you are defining the entity, the function prototype, as we said before, that you're gonna simulate. Good. Now before the begin, we're gonna put here what we call signals. Signals is different from the ports. They are not input or output. Okay, they are not input or output. So signals basically something can be, let's go back one step here. So basically input port and in port can be written only on the right hand side of assignment statement, and the output can be only on the right hand side of the of assignment operator. Okay, left hand side. So this is all output always left, inputs always right. And why is this? Basically because this is hardware. Okay, input cannot be output. Okay, and we use the input to find the output, but we don't do the opposite. Okay, so but signals can be either on the left or the right. Okay, good. Okay, so what's basically here you are doing, you are defining signals okay? And these signals will represent the inputs and the outputs. That's it. So the signals that you are defining here will represent your input and the output, okay? Then again, you write here the name of the designs that you want to use, want to simulate, I'm sorry, okay? So basically here you instantiate it. This is just a line line definition, we can say, you know. You can just write any name here, then colon, then the name of the name of the entity that you are simulating, which is AND gate, then port map. So you should, so we said that we created some signals here that will represent the input and the output. So which is which? So A input representing A, B input representing B. So we write it in the second place. And Y output, Y out representing Y. So, and the order here is necessary. You should order them. So A input, A, because A here is written in the first place. So we write A input first. B is the second. So we write B input as a second. Then Y, a third. Then we write Y out. Okay. Now it's time to give values and check the output. In the test bench, you give only values to the inputs, okay, to the signals that represent the inputs. We have two variables. Each variable is a Boolean variable, so it can have only 1 or 0. So we first give them 0, both A input and B input. Then we wait for some time, wait for 1 nanosecond, for example. And remember, this is a circuit. A circuit has input. Input is a voltage. This voltage is just a signal that you can see on oscilloscope, for example. Okay, it has a relation with time. So, for example, for 1 nanosecond it was 1, for 3 nanoseconds it was 0, something like this. After 1 nanosecond we change 0 and 1. Then we wait again. You know, it's not mandatory to use 1 nanosecond. You know, do it whatever. Do it in, just put some time. Okay. Then another value, put some time. Another value, put some time. Okay. You can use this as a template. So, you know, I will send you these files. You can use them as templates just to modify them in the future to reflect your new design. Okay. Good. We now finished this test bench. You compile again. Compile all. Of course, we don't have problems here. Yeah, 0 failed with no errors. Now it's time for simulation. So simulate, start simulation. Then everything you do will be put in a library called work. Okay, this is the default. You did it. So you just create a project, name it whatever. Okay, and whatever you create will be put in this work directory, or, you know, work library. So you open this work, okay, and search for AND gate underscore test bench, this file, this one here. Then click OK. This will change the view to the simulation view. So this is now the simulation view. Okay. So first you should fill here with the signals that you want to view. So we have here are the signals that you should view in your output. These are the inputs and this is the output. So you just control click or shift and choose all of them and just drag and drop. Okay, you can, you know. Good. Now this one here would be any value for just to make it 1 nanosecond. So just click here and you can change easily to 10, 5, you know, based on the application. I usually put it 1 nanosecond, but for some application I may increase it, and we will see now what it means. Okay. After we drag and drop and it changes to 1 nanosecond, okay, we have in our test bench here at least 4 nanoseconds, right? If you look at here this is the 0 nanosecond, and the maximum here is 0.6 nanoseconds. So you should zoom out a little bit. So you should search for this. If just click here, click here. So this will be activated. I mean the zooming. If it's not clicked, if we do this, it's not if we click here, it will not be activated. So just click here first. This will activate the zoom in and zoom out icons. Then yes, now it's 5 nanoseconds, which is basically more than what we need. Then to start the simulation, you just press this. This will make run, but run for 1 nanosecond. Then you can track, the change from 1 nanosecond to another 1 nanosecond. Okay, so let's do that. Good. Now 0 and 0. So look, A input is 0, B input is 0, Y output is 0. This is basically AND gate. We are still good. We are good. Another run, then 0 and 1 will give you 0. Yeah, actually, this is the second combination. Another run, 1 and 0 will give us 0, which is a third combination here. Then the fourth combination is 1 and 1 will give us 1. 1 and 1 will give us 1. Okay, it's very simple. Okay. And basically, if you continue, although we didn't write more here, it will stuck at its last value, which was 1 and 1. And of course, Y would be 1 at that time. Okay. One little trick here, you can, for example, change the color of the output. For example, whatever signal you want. So just right click here and choose properties. And here for the color, you can, for example, choose red. Just click close. Okay, look, it's red now. So you can track easily the output. Okay. Another trick is that you can even change the radix. I mean, either binary or hexadecimal or signed. Sometimes if you have a variable that has multiple bits, so it's easier at that time to see it as unsigned unsigned number. It will not change anything here because our variables are just 1 bit, so 0 or 1 all the time. Okay, but if this was multiple bits, then if it was 0 0, it will appear here as 0. If it was 0 1, it will appear at 1. If it was 1 0, it will appear as 2. If it was 1 1, it will appear here as 3, which is of course much better readable than tracing two signals on top of each other and try to think about the corresponding number for this combination. Okay, guys. So this is basically our first tutorial of VHDL. Okay, and each week we're gonna explore more. So thank you very much and have a great day. Bye bye.